Hello, congratulations on making it to this third and final instalment of these EasiBridge videos. This final piece will be a very simple overview of the various bridge types EasiBridge offers and other capabilities we can also provide. So at the moment, or up to this point, EasiBridge has been broken down into small, medium and large bridges. The first, small and medium, very simple, intended to be infantry capabilities. The last one, achieving 18-metre spans, may have required engineer input. So briefly, small bridges, very simple, up to 6 metres. We just lead plain ladder sections and no ropes. The key breakthrough with EasiBridge there is we can form these 6-metre bridges using this easy lock joint, so we don't have any rope bindings to form or anything like that. We simply clip the ladders together. What that means is we can also use those 6-metre ladders then for other applications. Vertical climbing, obviously, naturally this thing lends itself to being a ladder. And materials handling conveyor, we can use the trolley and the bridge to move equipment up a conveyor. More on that in a moment. Medium bridges up to 10.5 metres, still really simple. All we're doing now is adding 2 ropes to tension the ladder span, and we do that just with a single mast at or around the middle. So 10.5 metre bridges, that's what we're commercially offering at the moment, a very simple. These medium-sized bridges are also very handy as materials handling conveyors. So for instance, if we want to move personnel, casualties or ammunition up and down the outside of a building or even between buildings, this naturally lends itself to that. There's a brief video of one of these conveyors we use on a civilian site here. 18-metre bridges, this is where things get marginally more complicated. So now we're having 2 masts, twin stays at sort of third points typically, and we now need 5 ropes to tension that structure. This video shows our first 18-metre prototype. Now this is built of 12 1.5 metre ladder sections. This picture on the right shows the 1.5 metre ladders before assembly. The key breakthrough here is up to this point we weren't happy with our 18-metre systems. They worked from a technical point of view, but they were just too difficult to build. And the reason for that was the complexity in the end bay sizes, varying from 3.75 to 5.25 metres, and variations in mast heights. That's fine for a trained operator, but it was a bit of a head scratcher for someone who wasn't familiar with how to put these things together. Now, the joy of lockdown, we've had time to obviously stop production for a few weeks and actually sort of sit back and try and work out what could we do differently here. What sort of problems do we need to solve? And this is the solution we've come up with in the last 2 weeks, which I think transforms these 18-metre bridges. We've got a solution here which shows the end bays always staying at 5.25 metres on all spans greater than 12 metres. Mast heights always staying at 1200 millimetres for all cases, no variation. So I think that really unlocks 18-metre bridges, makes them viable for anyone to build. So what we're looking at now, if we can get this to work, if we can build it and test it, I think is any bridge up to 18 metres could be built as an infantry capability, no engineering input at all. So what will the engineers be doing with themselves? Well, this really is something that perhaps needs engineering input. I don't know. I still think this is reasonably simple and perhaps is an infantry capability again. So these are some footbridge systems we can build from EasiBridge. So first part of this video shows the tactical assault bridge, the trolley bridge coming together, clipping the ladders together, tensioning it with the mast in the middle, launching, inverting and crossing on the trolley. So that's the tactical assault bridge that's on the market at the moment. This is what we're now developing, this infantry assault footbridge version. So we add handrail posts, tie rods through rungs, and then we bring in handrails, which are basically just the ladders, the deck on its side. They provide enclosure so you don't fall off the bridge, but also significantly stiffen the bridge as a virandile down the sides. More than that was a simple single width narrow bridge. We can go to any width we want. So EasiBridge is modular. We simply slot more assault bridges side by side, tie them together with tie rods, and then remount these handrail edge assemblies on the side, stiffen up those edges, and we can then create much wider, much stronger bridges for multiple personnel or even light vehicles. So here's the first of those prototypes about 18 months ago. Again, this bridge is built entirely from 1.5 metre, 7 kilogram ladder sections, so 90% lighter than any other footbridge system on the market. We can also do lots of things with floating structures. We can easily put pontoons in our mast assemblies, so then we can create floating bridges, independent modular rafts, and then separate from that, we're actively looking at these quad LTMP ramps, and this just uses the ladders as sort of short gap 3-meter gap crossings for vehicles which otherwise wouldn't scale a 3-meter gap. Beyond that, we've got some autonomous placement ideas for bigger bridges using these vehicles. Key extended application for EasiBridge, and again, perhaps engineer input, are these force protection structures. So what we're doing here is turning the ladders into a roof truss. We're using the ladders in the deck, and we're using the mast elements are built from ladders also. So basically it's a framework built entirely of ladders and cables. Now this roof truss would offer a load capacity of around 3 tons per 6-meter span. That means we can cover it with blast protection, put a pre-detonation screen on it, and we've then got some very simple troop protection structures. Even simpler than that are these trench enclosure structures, where we just simply build a 3-meter span, no tensioning, and place those over the top of a trench or an enclosure, cover it with fill, and that gives some nominal blast resistance enclosure to that trench. Specialist access capabilities. The bridge is obviously, we've talked already, but what we want to talk about here is this fence breaching system. So this is a rapid scaling system for high security fences up to 4.5 meters. The trick here is we launch this thing just like we launched the bridge, but this time up in the air over a pole. That then gets us to a point over the fence. We have a midpoint articulating hinge, and that creates a giant step ladder. The entire framework only weighing around 40 kilograms. Key here is we don't touch the fence at any stage. So if there is damage detection equipment on that fence, we haven't touched it, it shouldn't be alerted. Next, these underbridge access platforms, where we can launch some ladders out sideways, horizontally, and then vertically, then horizontally, to create a platform underneath a bridge to get personnel underneath a bridge socket. Finally, these confined spaces bridges, so we can actually build 12-meter bridges from a 2-meter confined space. The trick here is to build the structures as you boom them out, and to use a very long carbon fibre nose extension on the front to get that reach to the building 12 meters away. But this really is where EasiBridge comes into its own, those modular short components that make that possible. Some conclusions. Well, key thing with EasiBridge are these component sizes. We've achieved something that's 90% lighter, I think it's 88% more compact than current systems. Doesn't quite achieve the same span, but certainly brings portability to another level. We've also got a number of unique super kit capabilities. So this isn't just single function equipment. We can build footbridges, we can build force protection systems, we can build all sorts from these. So the main benefits are portability. These are user portable bridges only weighing 5 kilograms a meter, very light, very portable. We can also use the ladders themselves to build carrier and casualty evacuation systems. Next, the span range. These are 18-meter bridges that can be installed by a single operative with access from one side only. Very light. Thirdly, cost. Obviously, these are just ladders ultimately, so reasonably cheap. Fourth, versatility. Using ladders in this way, if we think we've got a modular building block for gap crossing, force protection, carriage support, materials handling, and obviously being a ladder, vertical access. There's numerous capabilities there, but the main 4 to mention are this urban climbing conveyor, which we've spoken about, troop protection shelters and trench shelters, the fence breaching system, and underbridge access platform. The key breakthroughs that have got us here, well, we've tripled the span range from 6 meters for grass crossings up to 18 meters with EasiBridge. And we do that, but with the rope tensioning essentially. Next is the trolley that we use for crossing. Makes a very stable structure without handrails, and also allows us to launch the bridge as we've seen in those videos. Next are these easy lock joints. This means we can use very small components in our bridges, so ladders can be only 1.5 meters long, 7 kilograms in weight. The other breakthrough really is using the structure efficiently. So by turning the bridge upside down, which a single person can do, we create something that's really efficient for all scenarios. So for launch, we're keeping the ropes in tension. In operation, we're keeping ropes in tension. So really by inverting the structure, we just come up with an optimum structural solution at every stage. So we've tripled the span range from 6 to 18 metres. There's some complicated analysis to get us there, but in simple terms, we can sort of visualise this roughly as 3 6-metre crevasse crossings. So current crevasse crossings to do 6 metres. Imagine 3 bays of that. That gets us ish towards 18 metres. It is more complicated than that, and obviously we're actually creating a truss to do that. And a broad rule of thumb is that the beam capacity we'd get from these ladders is reduced by about 30%. Because we're also expecting the ladders to act as a truss member. Key breakthrough at the moment are in these 18-metre bridges. So this is the first prototype. Again, as I say, we didn't think this was viable for commercial release. It was too complicated for an unskilled operator. With this new concept we can see here, I think this is something that requires far less skill to assemble bridges up to any span. So overall summary, we've come up with a bridge which is 5 kilograms a metre in weight compared to 750 for general footbridges or 12.5 for the nearest equivalent military system. But the key breakthrough is the module size. We've achieved something here that gets to an 18-metre span but is 90% smaller, more compact than current modules of existing systems. That wraps up this entire presentation. I hope you found something useful there. I hope it's been a useful exercise. Thank you very much for your time. Much appreciated.